Okay, Auzubillahi minash shaitanir rajim. Bismillahir Rahmanir Rahim. I would like to welcome everyone to our monthly discussion, once again organized by Muslims in Research and Academics. And just to remind ourselves that Muslims in Research and Academic is a platform where young and early researchers, PhD students, is a platform where we meet every month and discuss various topics that would be useful in order for us to become better researchers and be better in our career also. And for this month, we'll be discussing a very interesting topic, and we have a very efficient person to discuss this with us. So this month's topic is on exploring the potentials of integrating no-code AI tools in academic research workflow. And as we all know, for this year, we've discussed like 2 different topics regarding AI, and we've realized the importance of AI in our research work. And AI is not just in the case of ChatGPT or Gemini or the different AI tools we are used to, that you ask a question, that you give it like a prompt to find this thing. Now, what is this one? What is this one? The use of AI there's more to the use of AI than that. And this guest speaker is going to it would be more like a mini training, I think, where it would put us through one particular AI tool that we can use in order to make our research work more efficient than what we are used to. A lot of us, when we are planning our research work, be it maybe you're doing your PhD or you want to write a paper or you have like a plan, we probably plan it manually. Maybe open your notes and say, okay, this is what I want to do, this is how I want to do it. But we also need to realize that AI can also come into play to help us to efficiently plan our research workflow and things like that. And to do justice to the topic, we have engineer Idris Munir here. So I'll just like read a brief bio about him. Engineer Idris is an innovative researcher with a passion for harnessing the power of AI to improve human health and well-being. His research area lies at the intersection of biomedical informatics and social engineering applications. Currently, he leads a team of researchers as the implementation head, pioneering Africa's first ECG repository and heart failure detection algorithm. He's also developing an AI-driven predictive system to identify the risk of intraventricular hemorrhage in premature babies, aiming to improve healthcare outcomes in Africa. Idris has a degree in electrical and computer engineering and biomedical engineering from the Lagos State University and the University Technology Malaysia, respectively. He is currently doing his PhD at the Industrial Engineering Department at Stellenbosch University, South Africa. So I would like to once again welcome Engineer Idris to the platform, and you can start your presentation now.
Okay. Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum assalam wa rahmatullahi wa barakatuh.
Yes, thank you for having me. And I hope at the end of this session, I would have been able to do justice to the topic. Like Dr. Zainab had said, the whole idea is to introduce to us the concept of no code. Sometimes we call it low code, AI tools that can help us to fill in the gap of some of the AI needs in our research. I'm not sure if this is the modality for presenting, or I have to share my put my camera on. I want to be sure of that.
Anyone is fine. You can put your camera on. I think
Okay.
it's better if you put your camera on.
Okay. Okay. I just want to be sure if this is modality. Okay. So what I'm going to be doing today is like Dr. Zainab said, it's going to be more like a mini training. I'm going to be introducing the tool to us, and then I'll also guide us through one or two workflows, and I will leave it to us to now see how in what part of our research does this workflow fit in. Let me quickly try to okay. Okay. Yeah. Okay. So let me try to share my okay, so somehow it has started raining here, and it might disrupt the connectivity at some point. So I hope you bear with me. Okay. Okay. So briefly, I'm going to be talking about no-code AI, and I will introduce to us properly the tools that I will be talking about, and a whole lot about the tools. And I would also guide us through building one or two tree workflows to see how this works. Okay. So, what no-code AI? I'm sure all of us are quite conversant with AI and all that. But then one of the problems is that a lot of people are still not taking out, especially academics, and especially if you are not from a coding background, if you don't have a coding experience, it becomes difficult for you to take advantage of AI in your research. But the good thing is that there are now solutions that allow you, even if you are a non-coder, to be able to, build simple and even complex AI solution on top of the data that you must have gathered in your research. And also another issue we have, even with some of the currently available solutions that Dr. Zainab mentioned, ChatGPT, a whole lot of them. There is this fear of what do they do with your data? When you give out your data, what happens? I mean, because it's more like a give and take thing. So if you upload the data and then you say, oh, ChatGPT, can you generate, can you analyze the result or whatever? What happens to your data? So so data security, data privacy is still a very big concern. But the good thing is that there are approaches to that, and you can literally fine-tune this state-of-the-art models on top of your own data. And you have those models running on your machine. But those approaches requires you to write, some codes, and it also requires to understand, coding on a very, very high level. But the good thing is that here is a solution that allows us to be able to cross that barrier. And at least we know that, oh yes, if there is need for us to implement, AI in our research, in our work, then there is a go-to tool that we need to go to. And so, like I said, no code AI. Sometimes we also try to be nice with words. We say low code. So low code would mean for people who are from a coding background, you can still use these tools by just tweaking the capabilities a little bit. But then the level of code you're going to be writing is going to be minimal compared to when you are actually at coding. I think in my bio, it wasn't mentioned that I'm also a professional data scientist of over 6 years, and literally I live by coding. So I know how interesting it is to code, and I know how difficult it is for people who are not from the coding background to 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 venture in coding, especially when you have to use it to solve um, very complex problems such as academic research problems. So the no-code AI is an approach to deploy AI solutions, and it empowers individuals with limited or no coding expertise to develop and deploy AI models. So what it means is that, I mean, you don't really have to worry so much about the coding. If you look at the graph on my right, it was a survey that was conducted by the Future CIO Tech company, and then they ranked one of the reasons why a lot of people are still not in terms of adoption. And I think this also boils down to academics also. And if you see on the second line is lack of talent with appropriate skill set for AI work. So what I mean, there is a lack of talented people who can literally sit down and write serious code. So because of that, we still have the adoption rate is still not as one would want to have. Yeah. Okay. I think someone might be on. HM. Okay.
I'm trying to mute.
Okay, so I think it's better now. So let me quickly just tell you that in the AI ecosystem, three things are involved. Any other thing is not part of it. Three things are involved: the hardware, the algorithm, and data. Hardware, alhamdulillah, the hardware problem about AI, about building sophisticated machine is already solved. The most capitalized company in the world, NVIDIA, as of last week, is that company that produces GPUs, which is the hardware on which many of the state-of-the-art AI models run on. So that has been solved. And as researchers also, we have opportunities to tap into this hardware free of charge. I've used a lot of, research support from Google, from NVIDIA, tapping on the hardware. So I don't even have to use my money to buy hardware. So that is solved. Then in terms of data is what we researchers actually generate in our work. Whether we are running simulations, whether we are going into the field to observe some parameters, what we are doing is we are gathering data. But we have data. But the missing gap here is many times is the coding skills. And sometimes when we are not the one writing the code, when we are not the one building the intelligence, maybe we are consulting that part to some other person, there is usually a disconnect many times. There is this still disconnect in terms of what you actually want in your head and what the person who is coding is doing. So it would make a whole lot of sense if you are the one, you are the owner of the research, and you're also the one building the intelligence behind whatever analytics you want to do on your research. So that is a brief introduction to the concept of no-code AI. I also like to say this, but I think I forgot to include that in my slide, that in the data analytics ecosystem, I think we have about 4 levels. The first one is usually exploratory analytics. I'm going to explain. The second one is diagnostic. The third one is predictive. And then the final stage is prescriptive analytics. So because of the lack of AI skills, many researchers, especially in the academic, usually stop at the diagnostic analytics. So what does that mean? You have your data, you collected your data and all that. You explore, You explore the data by running, descriptive analytics. You do some statistical analysis on your data to see the distribution and all that. And then you now do diagnostic analytics to know why. Why is this data like this? Why do you have this? Why do you have this? And at that point, many of us usually stop. So the next stage is now to say this data, is it possible to make some predictive analytics, meaning that, the next time we don't even need to worry about the actual data. Can we make future predictions based on the observation? So more like you're learning from the past. And the final stage is what we call prescriptive analytics, which literally means that you're saying, oh yeah, I want to have this result. What can I do to be able to achieve this result? So the focus of this talk would be more to prescriptive analytics. We all have a whole lot of software that help us to do the descriptive analytics. The diagnostic analytics many times has to be done by ourselves. That's more like we are interpreting the statistical analysis behind our data. But predictive analytics has to be done by the machine, not us. So, literally, the software I'm going to be introducing to us is an open source software. There are various ways we can implement no-code solutions in our work. We can decide to go for the online available ones and the offline ones. So the online available one, for example, you have Vertex AI by Google. You have Microsoft Azure ML from Microsoft. And then you also have Amazon SageMaker from Amazon. All of these platforms requires you to subscribe, so meaning you have to make some financial commitment, and then you must have internet to be able to use them. So usually for me, when I look for solutions that are usable in developing world, it has to be a solution that can do without internet and is also open source. So that's the reason why my go-to tool for no-code data analytics is this software that I'm going to introduce, which is called Nine. Maybe some of us have seen it before. It's Nine. So it's a standalone application, which means you can install on your PC, whether on Mac, Linux. It's also platform independent. So meaning you can install on any kind of OS you use, and it supports a whole lot of data types you can think of. It's just very, very, very useful. And I think as young researchers, if we adopt this in our work, it might make life a lot easier. So it's a tool that helps to do data analysis, data science, engineering, visualization, reporting, and all that. So literally, it uses the concept of visual programming, which means that you're actually programming by doing it visually, not by writing code. I love to write code, but I always say this, if you are learning to write code when you're doing your PhD, it's going to be very, very, very it's going to be very tasking. So, yeah, okay. So, okay. I mean, if you're lost in between my talk, you can just unmute your mic and then just pop your question, and then I can answer that so that we are all on the same page. It's a very long slide, but then I'll try to make it short as possible. So, like I said, all of the things that we've been doing up until now, it is possible to do in Nine. All of the things that we've been doing with our data in terms of descriptive analytics and also diagnostic analytics. Then on top of that, it is now possible for us to do predictive analytics, which is literally what the kind of AI we are talking about does. The AI that learns from data, it learns to predict the future from past observation. So in nine, basically you're going to be having two things, nodes and workflow. Like I said, nine is open source, so you can go online and just type nine. It's a German word, so the K is silent. So K is spelled Knime. The K is silent, and then you can download and install. And then when you download and install, we're going to be working with two things, nodes and workflows. So nodes perform tasks on data. I will explain. The workflows is a combination of nodes. So for example, if you want to explore, you've collected the data from observation, and then you want to explore, you want to describe, you want to run a descriptive analytics on your data. The first thing is that you have to read your data into the system. And when you read the data into the system, you give specific instructions as to which of the parameters do you want to look at and all that. So in nine, the component that helps you to achieve that is what we call node. So there is a node that if you drag it into the environment, I'm going to show you that. If you drag it into your environment, it allows you to be able to load your file into the system, and then you can, so each node would help you to perform specific tasks. So there are over 40,000 nodes for any kind of thing you want to do, for chemistry related experiment, for bioinformatics, for geospatial analytics, and a whole lot of that. We'll see that as we continue to. And then if you see below here, this is a workflow. A workflow. So a workflow is a combination of different nodes. For example, if you look at this, this is a node, a table splitter node. And from the name, it shows that you are splitting an input. What is coming into this will be splitted into two. And then you can see the output. So which means that one part of the splitting goes to this side and the other part goes to this side. And on the right here is what we call the workflows. The workflows are a combination of nodes. So what I want to do here, this line here, this workflow here, is to visualize a data of sales between 2018 and 2011. So I want to be able to create a report, for example, and I want to see. So this is a node. This node, from the name here, what do you think this node is going to do? Can we just put that in the chat? Let's make it more interactive to see if we are on the same page. The node here called CSV Reader. What do you think the node is going to do in this workflow? Anybody, please?
I think it will read the CSV file into the system.
Okay, it is. Thank you. So it is going to prompt you to navigate to where the CSV file is on your system, and then is able to read it. It's going to read the node. So nodes have three states. When you, I'm going to show you that. When you read your file, for example, here, the node, the initial state here shows that it is not configured. So when you drag a node and put it in your work environment, this is how it appears. It shows you that it is not configured. So when you specify the information, the parameter that this node needs, so this node needs the path to your file where the CSV file is. When you select that and it confirms that the path that truly exists, it becomes this, the yellow one, says configured. So the next thing is you have to run the node. So when you run the node, two things can happen. It is either the node is executed successfully or there's an error. So if the node is executed successfully, the button changed to green, which means that you have been able to successfully load the CSV file where you have your data from into the work environment. So, but if there is an error, it shows you this one, the error sign, to show that there is a problem. Okay, so, and you can see, so we've loaded this. There is an arrow that goes out of the CSV reader, which means that, oh yeah, we have something, data that we've loaded is going to somewhere. We have another node here. This node is called column filter. So this node, from the name, we want to be able to remove some columns. Select country, date, and amount column. So this is perhaps the column that we want to explore from all of the columns. I don't know the column, maybe we have 20 columns there, but we only want to focus on country, the date, and amount. That is what this column does. From the name, row filter, it means we want to exclude some rows. It says exclude rows where country is unknown. So it means anywhere in our data point, in our sample, where the country is unknown will be excluded from our analysis. Another row here called duplicate row filter. This means that you want to remove duplicate rows. And at the end of the day, we have a stack area chart, and we also have a pie chart. So we can visualize the data. And this you do without having to write any code. Like I said, these are also possible in some, imagine if you want to do this in Excel also. In Excel, you might also have to, write some commands at some point. So, okay, yes. Okay, so basically, when we talk about AI, what we are doing in Detroit data science, you try to visualize, you capture, you model, and all that. So I think we can skip to this. So like I said in the beginning, we have about 4,000 nodes in 9. Nodes will allow you to do specific functions, a whole lot of stuff. So I think when you get your hands on the software, you'll be able to explore many of these nodes that we have. For example, you can connect to your cloud, your cloud resources, Google Cloud, Box, and all that. You can also connect to your databases where you have your data, Excel, CSV reader, and if you also have your data in established databases and all that, you can do a whole lot of transformation and all that, and a whole lot of this. Okay, and then you can also deploy and all that. So I want to, okay, like I said, NIME supports all kind of it supports all kind of data formats, whether images, text files, and a whole lot of them, as you can see. Yeah, I want to quickly so do we have any question at this point, please, before we go into, and Dr. Zainab, I want to ask how much time do I have, please? Dr. Zainab, she here? Can you hear me, please? Dr. Zainab, can you hear me?
Oh, sorry, I was on mute. You have like 15 to 20 minutes remaining.
Oh,
I think yeah.
Okay.
I think someone wants to ask a question.
Okay. I think we need more time actually because they haven't gone into it. Okay, so please ask your question and then we just go into the
My question is, how can I know the nodes to be used for the type of analysis I have? For example, for bioinformatics data, how can I know the nodes that is suitable for that?
Okay, thank you very much. So like I said, I'm going to be sure. I think now because I've introduced this to us, I think I would have to show you the NIME environment, how it looks. I'm okay. So can we all see my slide, please? Can we all see this window, this particular window? Okay, yes. Okay. So if you install NIME, this is what you're going to have. You're literally going to have an empty workstation here. And then by this side, you have your nodes. And there are groups into what they do. If you come to this part, the menu, and then you install extensions. I just want to quickly answer your question. The extensions will show you, because when you install your NIME package, it doesn't come with some of the things all of the things you need. So if you need extra things, you can install extension. For example, if you're going to be using your NIME for bioinformatics related stuff, you come to menu and then extensions, and then you can see bioinformatics related stuff. I don't know, I think, but then if you come here, this all shows you all the nodes. For example, in bioinformatics, you can type bioinformatics. So for me, it shows that I don't have bio. So what do you do in bioinformatics? Tell me one thing you do normally. Can you hear me, please?
Okay, in that, try to compare some data. For example, to draw a tree, to know the generic the starting of that thing we are trying to analyze. So in mathematics, that allows us to bring different organisms together that way, and it can be used for other analysis.
Yes, I get that. So so like I said, I think I don't know why this is not responding. So once you install this, because this session is definitely the general one and not specific. Once you install the NIME, you can come to install extension, and then in here you have I don't know why the window is not coming out. You have a bioinformatics package that once you install that, it gives you different nodes with regards to, somebody is writing here. Okay. Somebody has access to, okay. It gives you a whole lot of options with regards to bioinformatics related stuff. So I think I need to quickly rush here. So these are all the nodes. Some of the nodes that are, okay, yeah, it's coming out. I don't know why. I think because I'm presenting, so it's a bit slow. I just want to show you, yeah. It's usually not slow like this, but then you are able to extend some of the things you have. Come on. Okay, so while we are waiting for this, okay, so maybe we can the sister who asked about the bioinformatics core option, we can have I mean, we can have a follow-up session so that let's just make it more general. I don't know. I think sometimes when you do stuff like this on Zoom, it slows down the network. Okay, so like I was saying about the nodes here, these are all the nodes. You have input, output. So from this, it means that what you're doing is you're reading and you're reading something, and then you're also generating output. And if you need to do anything, that you find them in the input output node. For example, if what you want to read is a CSV file, you just click on this and then you drag. So you have your CSV reader here. If the file is an Excel file, you bring it and then you drag. Sometimes it's always okay to just say a file reader. File reader would allow you to select what kind of, any type of CSV file. Maybe you want to read a faster file, for example, you can use this. Okay, so let's quickly show you that, and a whole lot of stuff like that. If you want to read an image, for example, you have an image reader, and then this image reader, if you, Okay, I think it's very difficult to run these things when you're on Zoom. I don't know. This is supposed to open a window and then you specify the path. Okay, yeah. So this is an image reader, for example. Let me try to find an image. So, okay, I have an image here, and then I click and apply. So you can see. So what this would help me to do is to read an image. So for people who are actually working on image related stuff, you can use this. So this is this is the image. I can view the image. So this is the image that I've been able to what's it called? I've been able to load into the work environment. The good thing is that image feature. So for people who are what's it called? Who work on images. For example, you want to be able to extract some features from this image. Okay, no, this one is I'm trying to see, let's say features. So sometimes you have to just type all those things out. We are still in the output. Sorry, I didn't know. I thought I had like 2 hours or something. Okay, image features. For people who are working on image and then you want to be able to extract image features. These features, so you have different, for people who are working in images, for example, first order and a whole lot of stuff. So let's say you want to extract first order feature of this particular image, and then you want to be able to use that in for some other analysis or something. If I click on this and then I run this, assuming you want to do this in MATLAB, you have to write code. So these have helped me to extract the first order features of this image. And let's say I have 20,000 images. I want to extract the feature and then I want to be able to do further stuff on them. I'm able to do that. This one says segment features. I drag that and I put it here. Come here. Okay. So what this is saying is that these features, this node and this node cannot work together. So it also help you to do the right thing. If it helps you to do the right thing. So that's regards to images. You can also work with audio files. Maybe you want to be able to do a voice, you want to be able to analyze, maybe you have observation of people's voice. And then you want to be able to analyze the pitch and all those audio features. You can also do that with NAM. So it's a whole lot of stuff you can do. So before we finish, I really want to show us one complete workflow implementation. Dr. Zainab, I would want to plead that you should give us more time because I was actually thinking, I think I should have asked that we have like 2 hours or something. So are we good?
Yes, you can.
Okay. So do we have questions at any point? Like as you can see here also, many times in our research, we also plot graphs and all that. So under this cluster of nodes here, you have nodes that can help us to plot different kind of what's it called, plots, bar chart, line plot, a whole lot of them, a whole lot, very complex one, very simple one that would have taken you, a lot of steps to come up with. So what I've done here is that AI is about making. Okay, somebody has a question. Fatima, please, can you ask the question?
It's not a question per se, but I just want to suggest that maybe you should narrow it down to a particular data. Like you should teach us how to go about your own particular data that you can easily learn from. I know it is a big
that's what we are doing now. Yeah, that's what we are doing now. So this is a case study so I have a case study here, and the case study here so it literally speaks to the two things we literally do when we build AI models. You are either, many times you are predicting. So your prediction can either be a categorical value, or you're predicting a continuous value. So in the AI machine learning ecosystem, we say regression or a classification problem. For example, you want to be able to determine whether a tumor image is benign or malignant. That, by looking at the features on the image, that is a classification problem. For example, you also want to predict the what you call, you want to predict the VOC, volatile organic compound value, from some features and all that, because that is the continuous value. Say that is a regression problem. So what I have here is I have two workflows. The first one talks about a linear regression where we are predicting a continuous value, and the other one talks about a classification problem where we are predicting a class. So the first one here, okay, the first one here is okay. So we are predicting the number of hours, weekly hours, someone is likely going to work based on a lot of information. So the table reader here, it helps us to, so I'm going to show you what the data looks like. So this is the data. This is the data we are going to be working with, and it has so many features. I mean, sorry, it has not so many. One of the features here is age, the work class, whether the person works for the government, self-employed, private, you know, 3 classes. And then you have marital status. The person has been married, never married, divorced, and all that. Occupation, relationship. And based on all of these features, we want to be able to predict the number of hours the person is likely going to work per week. So, and because the number of hours is also a continuous thing, it can be anything. It is, so we say it's a regression problem. So with this, we read the data, and then this also also, because in our data sometimes we have what we call missing values, and I'm sure we can, all of us can relate with that missing values when a particular value is missing in our data point. This would help us to deal with missing values. So let's see what is in there. So here, what I've said is that for any missing value, replace it with 0. So anywhere there's a missing value unknown in our data, it will be replaced with 0. Okay, so in building AI model, what we do is when we have our data, we don't use the entire data to build our model. We normally divide the data into 2 parts. We use one to train the model, and we use the other part to test whether the model is able to predict on unseen data, which is what we actually want. We want to be able to, like I said, predictive analytics. So your past data, the data you're building the model on, you want to be able to evaluate the model at the end of the day, whether it will be able to, you know, make accurate prediction on unseen data. So from the name, you have a node called partitioning. And what does this do? It partitions the original data you have into 2. There are various ways you can partition. So this one, take from top. So what is this one? If you say, it means it will just pick it from the top. But what I've done here is to draw randomly, which is the best practices. So you just draw at random, and then you are saying relative 75%. So it means that 75% of your data will be used to train the model, and the remaining 25% will be used to test whether the model has learned anything or not, whether the model is usable or not. Okay, so when you are building your model also, there are various ways you can build a model, which is what we call algorithms. Algorithms are different techniques you feed your data into to build your model. There are different ones, a whole lot of them. Linear regression, support vector machine, up to the almighty deep learning algorithms. So in this case study, I use the linear regression, which is very simple. I think most of us would have been used to that. It's a very simple, it's probably simplest machine learning algorithm you can think of. linear regression. So I want to build a linear regression model that will be able to predict the number of hours, working hours per week based on the feature. So if I drag this and I connect this, meaning the data is going in here. So I want this to learn. If I click on this, I can select the features that I want to be part of the features. You know, we talked about independent variables and dependent variables. So our features are the independent variable. The dependent variable is the variable we are predicting, is the target. So for this study, the target is hours per week. So it means we want to be able to use all of these features, all of these other features, we call them independent variables, to be able to determine hours per week. You can start thinking about that in your own work too. You want to be able to use some features to predict the chemical properties of a particular substance and all that. Okay. Okay. So I have this. And then once I run this, the model will train. And once it's done training, you see, once you see the green button, it means it is done. The next thing now for us is now to test the model. We've trained it. It's like we've teach the model. So now we want to do an exam. The 25% data that we have, we'll pass that into, and you have to know this. This is a linear regression learner. We must also get a regression predictor to be able to, that is compatible with the learner to be able to do the prediction, or else it won't work. By the time you test your hand on it, you've trained. So this is more like the brain will pass it here. And then the data we are trying to test will pass it here. And then we'll run this. And then after running this, we now want to evaluate the result. So if you see here, all of these features are the ones that we pass into here. And then this is the prediction. If you see, so it's showing here that these are prediction column here. The prediction is predicting, this is the actual number of hours, 40, 40. And then our model, the prediction for the first data point, it predicted 37, 39, 47, and all that. So how do we evaluate this model? There are metrics for evaluating. Because this is a regression problem, it is more, so it is what we use to evaluate. You can use the R-squared, the mean squared error, you know, MSE, and a whole lot of metrics like that that you also know. So numeric scorer would help us to evaluate how well the model has done. The reference column, which is the target column, is this one. And then the one our model has predicted, the name is prediction hours. So when we run this, we are able to see the outcome of the result. It shows us that the R square for this model is, this is what's this? This is 18.1, no, this is 18.1%, which is very, very bad. And then you have the mean square error, which is not, I mean, so what we have been able to do is that we've been able to go through the entire pipeline, although the metrics are not good. So what we do is to fine tune some parameters to make sure that we have a good model, because this is just very simple. So that is that about the workflow for a regression problem. This is another workflow for what's it called? A classification problem. So we are using the same data. Classification, like I said, you are predicting classes. So in this case, we are predicting the class of income where this person belongs to, whether the person's income is greater than 50,000 K or less than 50,000 K. That is just two classes, a binary problem. So we are also using a different algorithm. Like I told you, the algorithm you use differs. So this one, we are using what we call the decision tree learner. And then going through the same process, you have the decision tree. Here we are predicting the income. Okay. And then we have this and we run it. And at the end of the day, we have our way of seeing how the result looks like. For classification problem, we usually use the AUC ROC curve. It's a very, very efficient way of knowing. This is very good because now it's saying that we've been able to build a very simple model that is able to discriminate people that have income above 50K and less than 50K by 88.5%. So that means the discriminative power of the model is very good. Okay, so that is how, so the algorithms are the nodes also. That's, I mean, if you go to analytics, under analytics, you have many of those, and then as you try your hands on it, you are able to master one or two things. So this is just an introduction to what we have. Aside machine learning problems like this, you can also use 9 for some of the things you do with the LLM, the large language models. For example, you want to be able to do sentiment prediction. Maybe you are in social art, you work in social art, and then you've been able to go to the field to collect, textual information, and then you want to be able to understand the sentiment in those statements. You can also use 9. So this is one pipeline that helped us to do sentiment analysis, taking advantage of the large language models like OpenAI and all that. And I think finally, before I go, I was just trying to show something here, which is quite interesting to show you. So there's a concept in the AI domain which we call embeddings, which is actually what is making us achieve all of the things that we're achieving in the AI domain. For example, you have a lot of textual information, and then you want to visualize how close statements are to one another. You can also be able to do that. This is one simple pipeline that allows us to do that. And then eventually it shows us something. I just want to share this because it's quite interesting. So here I have, what happened? Okay, let me just show you this. I have a simple pipeline. You can follow up with me. Okay, I have a simple pipeline of different statements, and I want to see how close these statements are by visualizing them, not even reading through them. These two statements are very close. This statement, I think I said all religions preach. Let me look at the actual text here so that we understand how useful this software is. Sorry. Okay, table. Sorry. So, okay, yeah. So look at this statement. All religions of the world inherently preaches love. However, the custodians changes the message to suit their respective narrative. That's one statement. The adherents of the different religions are the major creator of the Trinity. Religions inherently preach love. Ronaldo is a good lover of football. So we have this statement, and then we want to see in the larger scheme of things how, for people who are working with related to text, might be able to understand this. Even for somebody who works in bioinformatics, you can also be able to use things like this to see. So what I have here now is the visualization of those texts in an embedding space, and you can see these two are closer simply because the meaning look the same. This one is the adherent of the religion, and this one is all religion. And then you see this one, alligators are, this one, they are far apart because conceptually they don't share the same concept. So I think I would want to stop at this point here, and maybe we'll take questions. Thank you so much. I hope I've been able to introduce the solution to you properly. Thank you.
Yeah, thank you very much, Engineer Idris. And this has been a very good introduction to this, and I believe that with this brief training, a lot of people would like to explore this further to understand how they can use this in their research work. we have some questions in the chat box. I don't know if you can go through them first before we take any additional question.
Okay. Oh, it's a lot. Wow. Okay. That's good. Okay. Based on the data, okay, it can read images. Yes, I think I said that. Does this mean it can build an AI model for visual? Absolutely, yes. Images are numbers. So if you read your image, what you're doing, you can extract features from the images. And on top of that, you can build whatever you want to build. I don't know if that answers your question, Rashid Bello. Does that answer the question? Rashid Bello, okay. Based on the data, can NIME give us an option on what algorithm to use? Yes, okay, I think because we don't have time, I'm sorry. So yes, there is what we also call AutoML. The option is also in NIME, which means automated machine learning. So for people who are also not from a computer science background, who don't know exactly the algorithm to use, you can use what we call AutoML. I would have loved to show you a solution. If time permits me, I'll try to show you that you can use AutoML. So AutoML means automated machine learning. It helps you to automate the entire machine learning pipeline. So what you need to focus on is your data. You feed in your data into the AutoML pipeline, and then it generates the result. So based on your data, it feeds your data into so many different algorithms, and at the end of the day, it selects the best for your model. So there is an AutoML option in NIME. Another question here is also, do we need to know the next node to add, or will NIME also give suggestion on what next to do? So the good thing about NIME as it stands now, it doesn't give you but then there is a KI assistant that can help you. So if you want to do anything, you can type in here, like you're also doing ChatGPT. You can ask questions that, oh yes, I want to build a model based on this data. And then can you suggest the pipeline? So to suggest the node to use. But like I said, the moment you familiarize yourself with the environment, you'll be able to know the node to help you to do your work. It just requires some level of practice. And the good thing is that the names of the nodes are quite informative. Okay, so let me go to the next question. Okay. Okay. I think this still needs you to understand the basis of data science, feature and target matrices. Correlation is remove the burden of writing code. And like I said, so for people who are from a data science background, it makes your work a lot more easier. For people who are just coming in, it makes it easy to come into the data science, fold, and it makes it easy for you to just implement simple, AI solution in your research workflow without having to worry too much about writing codes. Another, I can imagine how long it will take me to write code before evaluating. Okay, thank you so much. Yeah, so that's the goal. That is the goal. I think we need part 2 of this session. Okay, and Dr. Zainab would. Okay. I think I've taken all the questions in, but Ajadi Sadiq.
Yes.
As maybe you want to say something. Yeah.
Assalamu alaikum wa rahmatullahi wa barakatuh.
Wa alaikum salam.
Thank you so much for your time and for taking us through this excellent software. So Peter, okay, my own background, I'm a geospatial scientist with a focus on climate change, and I heard you about the application of this 9 geospatial science. Also.
Yes.
I don't know if we are going to organize another session, or if possible, the way we can further discuss.
Okay, so for specific use cases, I would advise that I will drop my email address, and then maybe you can reach out to Dr. Zainab told me also. So for specialized cases, we can have personal sessions. Yeah.
Okay, thank you very much. Is there any other question? This brief training that engineer Idris put us through, I can imagine how much some people would have to pay for this. So Jazakallah khairan for doing this for us. Really appreciate it. May Allah reward you abundantly. May Allah grant you ease in your affairs. Really appreciate this. Is there any other question before we end today's session?
I'm trying to share this workflow. Maybe we can before the meeting ends, we can download, and then please just download the software. Like I said, it is free, it is open source, it doesn't require internet when you're using, except when you're doing some authentication and all that. So it very, 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 very useful. And yeah. Oh, so, okay, somebody just said something. Let me answer that. Says need another case for social sciences management. I think, like I said, okay, I think for people in social sciences and management, the problem might be that you're just coming new into data science. So for me, as a data science person, or maybe there's another data science person here, what I've just covered here even speaks more to, oh no, NIME is more than Tableau. Tableau is just for data visualization. NIME is a complete data analytics tool that is way, 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 way ahead of Tableau. Tableau is data visualization majorly, but NIME is a whole lot of stuff. It's a whole lot of stuff. Please, I'm begging you, install this, and then you see how amazing, how big this, and the good thing is that it has a lot of research support. The geospatial analytics package for NIME was developed by Stanford University. So that's one of the things I also look out for. I didn't just look out for softwares that are just, no, I look out for softwares that are research backed. So, and many of the bioinformatics, a whole lot of stuff. So they have collaborations with many of the top research institutes, because they've discovered that researchers don't really have to code, but researchers need to use coding backs and softwares to be able to do better. I mean, to be able to, do their research properly. So why not, put this in a way that is easy for them to use and all that. So please let us install this, and then this is my email address. I don't know, Dr. Zena, am I allowed to do that?
You can, or you can send it to me personally, because we have like a WhatsApp group, so I can also share it there for those that would like to communicate with you.
Okay. And so, okay, I think I would also share this workflow with you then, and then you can share.
You can drop your number, Rashid Bello, so that I can add you. Your WhatsApp number.
Okay. Okay, I think it should be. Oh, okay. You want to add me to the group, right?
Well, if you want, we can add you to the group also.
Oh, no, okay. Okay, Rashid Bello is dropping his number. Okay.
Yes.
Okay. All right. It's fine. Thank you. I think I'm glad that I'm able to. I'm sorry. I actually thought it was 2 hours, so
you said you want to drop on file or something like that.
Sorry?
You said you want to drop your file.
You said what?
Okay.
You said you want to drop one file on the chat box.
Okay, you
yeah,
said you were going to drop. Yes.
The workflow, so that we can also download it. But the good thing is that NIME also has a very robust community, and yeah, it's a very nice stuff to explore. I don't know. Yeah. Okay. Oh, okay.
Okay,
So where's this?
thank you very much, Engineer Idris. We really appreciate this, and if we need like another follow-up session, we hope you will be available for us to take the session. Jazakallah khairan. Let me wait for you to send the workflow, or you can send it to can you send it to WhatsApp instead?
Yes,
So
I'll do that. I'll send it to
so I
WhatsApp.
can forward it.
Yes.
So with that, we come to the end of today's session, and inshallah, next month we would have another session with another interesting topic that will be beneficial to everyone. I would like to say Jazakallah khairan to everyone for joining. I really appreciate you. And again, Jazakallah khairan to our speaker, Engineer Idris Munir. Thank you very much for this session. I remember I told you just a few weeks today, and you agreed to discuss this with us. I really, really appreciate it. Assalamu alaikum wa rahmatullahi wa barakatuh to everyone. And with that, we come to the end of today's program.
Definitely.